Hello there, it's Jay here from Jay's Vintage Junk, and today this is going to be part 2 of the little Spectrum 48K repair, restoration, whatever you want to call it. And today, as I promised, I thought we'd have a look at the capacitors which we took out of the old 48K board. Now what I thought we'd do is we would test these capacitors, and we're going to test them for both capacitance and for ESR, which is equivalent series resistance. And what I also thought we'd test is what I've got here, which is 2 brand new, in fact these only came in the post the other day, so these are brand new capacitors. They're not any particular fancy make or anything. These are, don't know if you can read that on there, probably not, this camera's not good enough, but they're Jamicon, so they're nothing special, but like I said, those are brand new. These are new old stock. I got these off a mate of mine a number of years ago. He used to work for Ferranti back in the 80s and early 90s, assembling various bits of military hardware. Excuse me. And he was clearing his cellar out and come across a load of components and said, did I want them before they went to the tip? So that's where I got these from. What we've got is these are Rubicon. So these are like top quality capacitors. We've got 100 UF and 22 UF. Same there, we've got 100 UF and 22 UF. But these are probably 25 to 30 year old. But like I said, they're brand new, never used. So we'll compare them. We'll compare them, and we will compare the capacitors that we took out of the Spectrum, which incidentally are, what brand are these? These are Chamois. These are Chamois branded capacitors. And what did we install in the Spectrum board? I think there would probably be something like Nichicon or one of the better modern brands. Let's see what we used, because they all come in the same kit. I think it did tell us they were a fairly decent brand. Can't read it on that one. Let's have a look at this one. This incidentally is the part of that little composite video mod board that came with it. Can I read that one? Ah, yeah. Oh, yeah, they are Nichicons. So, yeah, they're a fairly decent brand. I've never had a problem with Nichicons. In fact, we will, what is that? That's a 4.7 UF, so we'll test that as well, because that's the same brand as what we fitted to the Spectrum. Just put these away for the time being in their little bag. I think that's a Nichicon as well, but I can't quite read the printing on that one. Right, and what we're going to test these with? We're going to do 2 tests. First of all, we're going to do the test that if you've got one of the better multimeters, it usually has a capacitance range on it. And you can have little standalone testers like I've got, and they just measure capacitance. The one that I'll be using today measures a few other things. I will just bring that in shot, because I'm sure you're familiar with it if you've watched any of my other videos. And that's this thing here. Now all this is it's a cheap board you can buy from China. It's just literally a little circuit board like that. And it tests transistors, it tests resistors, it tests capacitors, it tests diodes, and it just gives you the value, basic specs on them, whatever. It doesn't do an ESR test on capacitors, and this particular one can't test inductors. Some of the slightly more expensive ones can. That board I think cost me between 10 and 12 quid delivered from China. The box is just a repurposed box from something else. I added the connectors on it. I also added a little continuity buzzer on here, which makes it just a handy little test device. But we will go through the capacitors with this first and see roughly how close to the actual capacitance they are. I don't think I'll go through all of them. I'll just do like a random selection We'll do a few of the 22 UF ones because there are quite a lot of them. Now let me see if I can get the camera perhaps a little bit closer to the screen so you can read it properly. Let's bring that in like that, and let's select one of these capacitors. This is a 22 UF, one of the chamois ones that we took out of the Spectrum. Now with this tester, there's no polarity on it. There's 3 leads. If it's a 2 lead component, you just pick 2 of the leads. It doesn't matter which ones. Clip them on to the tester like so. There we go, and you press the button. And as we can see there, it is telling us that that is a 19, I can't really see this very well, oh, I've got it angled here, I wonder if I can see that. Yeah, it's 19 point odd UF, so it's within the 20% tolerance that most of these little electrolytic capacitors are. So that's one of the original ones. That's still on its capacitance value. Let's have a look at this one, another 22 UF. Let's connect that up. Like I said, we don't have to worry about which polarity we use. Let's just connect it to the meter. There we go, and press the button. Let's see what this one tells us. Again, you know, 19.67 UF, so with its tolerance, yeah, that's still about where the capacitance should be. Let's try this brand new one. We've got a brand new one here, and that's 22 UF. Like I said, this is a cheapy. I've got these in like a bulk kit of various values. They were very cheap. I think 100 capacitors, and it was under 10 quid delivered. So let's see what this reads. 17.54, so it's a bit more out of tolerance than the others. Like I say, it's a cheap capacitor. Let's try one of the new old stock 25 to 30 year old Rubicons. Oh, the Rubicons, these. Did I say that? Yeah, these Rubicons. Connect that to the meter. Press the button. What's that telling us? That one is 18 point, so that's 19 UF. Again, it's about the same as the chamois ones that we pulled out of the Spectrum, even though it's, like this, 25 to 30 year old, that, but it's never ever been used. We'll try a couple of the higher value ones. Let's have a go with some of these 100 UF. Again, we'll just connect it up to the meter. Take a press. 97.29 there, so again that is almost bang on. It's a its mark value for its capacitance anyway. Then let us try one of these, if I can find what I've done with it. Let's try that brand new one. Again, that's 100 UF. We'll connect that up. Cheapy one. And that is showing 81.64 UF. So again, it's not as high a tolerance as the old ones. We'll stick that, and we'll try the that other 100 UF new old stock Rubicon one. Again, we'll connect that up to the test meter. Press the button. And 89.34, so it's not far off. Like I say, it's within the tolerance, and like I said, that's 25 to 30 year old. But to be honest, that is not the best test you want to do for capacitors, especially not in like the Spectrums where they're used for DC coupling and things like that. And to be totally honest, unless something really nasty's happened to the capacitor, the capacitance doesn't really change that much, because the capacitance is it relies on the amount of foil inside the capacitor that's rolled up. That's how it actually you change the value of the capacitance in a capacitor, is by changing the surface area of the foil inside there. Now, as the dielectric, which is like the liquid between the two plates, there's a paper with that's soaked in like a liquid, a dielectric, that goes between the two pieces of foil inside the capacitor. And as that dries out, the capacitance of the capacitor won't change, but the equivalent series of resistance of the capacitor will increase. Now that's what you don't want, because as the resistance increases, the current draw of the capacitor increases, the capacitor actually starts producing heat, which obviously then makes the electrolytic dry out quicker, and eventually you get a capacitor which fails completely. It can short out, you can have all kinds of problems. So it's not particularly the capacitance that we need to worry with these, it's the ESR on them. So instead of using this meter here, what we need to use is something like this meter here. Now let me see if I can actually get this so it focuses right down on the meter, so you can actually see the printing. I don't know whether we're going to get this or not, to be honest, because this camera's crap. No, what I'm going to have to do, I'm basically going to have to show you what this is. It's not picking it up on the camera. What we've got is, this is like one of the cheap, let's just zoom it out a little bit, because you'll still be able to read what it's saying. What we've got here is one of the cheapest ESR meters really you can get. You can get kitty type things, but as a proper built unit, this was, I think it was like 28 quid. It was under 30 quid delivered from China. It has its own rechargeable battery inside it. It comes with a little USB lead, so you just plug it into a 5 volt USB power supply to charge it up. It lasts for, I can use it all day on a charge. It's quite good in that respect. Possibly it might have been better with a replaceable battery in it, I don't know. This is just how it came. Like I said, cheap as you can get, but it will test all your capacitors for their ESR. What we do with this is a little chart which unfortunately the camera's not picking up here, so I'll have to explain how you actually use this meter. First thing we do is we power it up and switch it on. Hopefully you can see that. It's asking me to basically short the probes together so it can compensate itself. So what we will do, all we do is just connect the probes together like that. It's now calibrated itself. As you can see, it's showing 0.000 ohms. So we can disconnect that now. And what we want to do is we want to put a capacitor in test. So let us start off with, we'll start off with the 22UF, really cheapy, modern brand new capacitor. And that is 22UF, and it's actually rated at 50 volts. Now the chart on here, you read off the voltage down and you read the value of the capacitor across like here, and basically it gives you a value, and it's only a rough estimate where they cross, and if it's basically higher than that value, then the capacitor's no good. If it's lower than that value, then it's fine. The lower it is, you want to get as close to 0 ohms basically as it will go. The capacitor's okay. If it's higher than the lowest value on there, then obviously there's something wrong with the capacitor. It's got high ESR. So let's start with this 22UF 50 volt. Now it's got markings for 35 volt and 63 volts. So if we look at 22UF, we're looking at 63 volt is showing 1 ohm as the minimum, and 35 volt is showing 1.2 ohms. So we're looking for something between 1 ohm and 1.2 ohms for this capacitor to be considered okay. A little bit higher than that, being that this is a really cheap meter, you'd still be probably okay. If it's in magnitudes of ohms higher than that value, obviously there's something wrong with the capacitor. So let's connect this up to the meter. Negative on that side. I'm not showing that on camera, am I? Negative on that side. Connect positive on that side like that. And that is showing 1.67 ohms. So onto this 1 to 120. You know, for a modern brand new capacitor, that's quite a crap capacitor, really. I wonder if I should test another one out of the same batch, see if they're all that bad. Just give us a sec. I was expecting that to be a bit lower than that value. Okay, we have my selection of capacitors here. Not that you can see it very well, but let's get this open. Let's try another one of them brand new ones, because you do have to be careful. Sometimes you can get a duffer. That's why I always tend to test capacitors before I fit them into a circuit. Right, so let's try this one. This is, again, it's 22 UF 50 volts. Just see whether that was a one-off bad one, or these are just not very good capacitors. 1.84, that's even worse. So these are, they're not lower ESI capacitors, we can certainly say that. So would I use them for replacements in a Spectrum? Probably not. Right, they'd be fine for what I actually buy them for, which is messing about with circuits, using them on prototyping board, things like that. Most of them are messing about with RF stuff, so bit of ESR, yeah. They're fine for what I use them for. Would I use them as in a decoupling roll in a Spectrum? No. Next, we have got that 25 to 30 year old 22 UF Rubicon. Let's try that, see how that fares out after all these years. Bear in mind, it's brand new, never been used, but it has got some age to it. So we connect that up. Connect that lead like that. And even, I mean, yeah, it's showing 1.25, so it's a damn sight better than that brand new one. But even so, I mean, it's ballpark. It's fine. But if it was much higher than that, or if it had been in use for 20 odd years, I'm probably thinking about replacing it. Would I use them as replacements in a Spectrum? Probably at a pinch. If it was my own Spectrum, would I use them in repair? Well, would I use them in one of my refurbished ones that I sell? No, I wouldn't. I'd use a good brand new one. But a repair for my own computers or something I'm just fixing up, yeah, I'd probably use one of them. Because it is in spec, and it is a good brand. Now, I wonder how these are going to fare. We have got one of the 22 UF 25, oops, flying off shot. We've got one of the 22 UF 25 volters that chamois ones we pulled out of the Spectrum. Quick look round it, and it doesn't appear that it's been leaking any electrolyte from the end, because sometimes you can see some white deposits on the end there, on the black end, when they've been leaking, so that looks alright. We'll put it on the meter, and that's the definitive test, really. So negative to that side. Another little trick: if these capacitors aren't marked with the arrows to show which the negative is, generally speaking, if you look at them, one end will have the lead soldered to the case like that, and one end will have a bung in it, either red or black, or I've seen some other colours, but it'll have a bung. Generally, the end with the rubber bung in it is your positive end. The end that's soldered to the can is the negative. Not always, but if there's no other markings on the case, then generally speaking it's that way around. Anyway, let's let's test this one out of the old Spectrum and see what it comes out at. Oh wow, look at that. Now, after all these years, bear in mind, we've already ascertained that that's still in value, capacitance wise. That's actually very, very low ESR. It's lower than the modern El Cheapos. It's more lower than that Rubicon that we tried. That's very, very low ESR. So, am I glad that I've changed it? Well, no, there's nothing wrong with that capacitor. But like I said, I like to sell these with a complete new set of completely recapped. So even though that's good, it's still it's coming out. let's try another one of them. Again, yeah, this is a 22 UF. We'll connect it up to the meter. And yeah, wow, again, same. It's these are really nice low ESR capacitors. Let's try, I know what I'm going to try. We've got one of the Nichicons here, which is the same brand that I fitted to the Specky board. That's a 4.7 UF. It's only a 10 volt one, but what we'll try, I think I've got a 4.7 UF here that we took out of the Spectrum, and let's compare them two and just see. I'm sure I've got a 4.7 in this lot. That's 22. I think I've lost it now. 22. 20. Ah, there it is. So this is the 4.7 UF at it's 50 volts, but really we're not interested in the voltage rating, not for what we're looking at here. All we need to look at is that 4.7 UF capacitor there has spent, since what, 1985, 86, whenever that computer was made, 1985, sat in a 48K Spectrum which has been used. That is a brand new modern replacement capacitor. So let's just see what the ESR on these two is. Let's go with the modern one first. Plus and neg. Now we've got an ESR of that of 3.28 ohms. So let's check this on the scale. We've got 10 volts and we've got 4.6. Well, it doesn't actually do that. We'll have to go up in voltage, and it's saying 6. So 6.5. Yeah, there's nothing wrong with that. That's well within the ESR. You'd reckon the ESR probably for that voltage rating would be around the 4. That's 3.34, so that's fine. Now this is a 50 volter. Again, we don't have an actual. We've got 35 volt and 63 volt, and at 4.7 we've got 2.8 ohm to 2.5 ohm. So we want something 2.6 ohm-ish, or anything below that, and we should be about fine. So let's connect this up. Let's positive to that end like that. And wow, that is really low again. You've got 0.69 ohms. So these chamois capacitors used in the later, because this is a 48K Spectrum Plus. It's one of the last revision ones, I think. These chamois capacitors that they used back there in them, they really are very good quality, I must admit. Only rated 85 degrees C as where the capacitors that I've replaced them with, I think are actually 105 degrees C rated capacitors. So, given that they're going to be run at much lower temperature, they should last quite a lot longer. I don't really need 105 degree capacitors in a Spectrum, but if that's what you've got, fit them. It's not going to cause any problems. So, in conclusion, I don't know really what to conclude about this. Some don'ts. Don't recap your Specky with super cheap non-lowest ESR, no name, no brand Jamicon capacitors, because I'm pretty sure you'll be doing it again in a few years' time. Said they were really quite high ESR for brand new. Again, these nice Rubicon ones, I would certainly use them in repairs of my own stuff. I just wouldn't use them in restored computers that have been all, which I like to recap with all brand new components. I will use a good quality, like the Nichicons, for that purpose. So, but they're fine. They're fine for my own use. and the chamois. Well, when I sell a Spectrum, I always make it as a point that they are fully recapped with new capacitors. If I was doing a repair for a customer, someone said, "Can you fix my Spectrum?" I'd certainly test all the capacitors. But if they were these chamois ones, and they were testing go, I don't think I'd bother replacing them just as a matter of course, just because they need, just because you want to recap the Spectrum. Certainly you do need something like this to be able to make that judgment. I would never make that judgment without owning an ESR meter, so you can actually test the capacitors. Other nice thing about this is you can actually test the capacitors in circuit. It uses such a low voltage and it uses a high frequency that the other components in the actual circuit don't really affect the readings. So, like I said, you can use this for in-circuit testing. Yeah, I'm going to leave it at that. Bit surprised at the results there. I was expecting at least a few of these old capacitors to be bad. I'm not going to keep them. I actually have a friend that makes jewellery out of old components, so they'll go in the pot for her to take to her Rangers group and use to make jewellery with. But yeah, I thought you'd find that useful and interesting anyway. I will be making at least one more video on this subject. Namely, I'm going to give the keyboard a bit of a service and a clean. Like I say, it's fully working, but I'll strip it all apart and give it a clean up. And we're also going to have a look at them alternative composite video mods. Basically see whether there's any real significant difference between doing the mod that I usually do, doing the one that uses just a capacitor, and doing the one that uses a transistor. And I may have a look at, like I said before, an idea that I had for a bit of a mod. It's a bit better matched impedance wise than what you normally get, but that's just in my mind. I don't know where I'll get round to that. And that brings me to my last point, is that hopefully I can get that video out before next Friday, but if I don't, there's going to be a little bit of a delay. On Friday I'm actually off on my holidays. I'm going to be out of the country for 6 weeks. I'm going to Italy for 2 weeks. I'm touring Italy, and then I'm flying off to China for a month. So obviously I might put the odd status update up on my Facebook and things like that if you know me through there while I'm in Italy, but I don't know how much contact I'm going to be able to make when I'm over in China, because they don't have Facebook. Well, they do, but it's not easy to access. And I don't believe you can access YouTube from China either. But anyway, I'm sure I'll have lots of things to talk about and interest when I get back to the UK. So I will leave it at that for now. Hopefully I'll have a video, another video out about this Spectrum before Friday, but if not, you'll have to wait till I get back. So thanks for watching that, and goodbye.